axis, asymptote on the y-axis. Golf ball -1 goes to a depth of 1 unit below ground. That's the point, -1, comma, -1. Let me zoom in on this a little bit in case you're having trouble seeing it. So that's an example of what I would expect for a quick sketch. And then, you can look in the printout of quick sketches to see an example of that. So make sure that you know quick sketch 1 through 8, 13, and 14. Alrighty, so that was the quick sketch objective. Next, I'm going to do a few examples that I would expect you to do for assignment 10.5. Okay. Yeah. All right, page 166. I'm just doing an example from the book. Page 166, number 38, is a non-quick sketch. You take a look at 166:38. It says f of x is x divided by the absolute value of x. That's not one of the 48 quick sketches, but you can sketch a graph by looking at two cases. You can consider the case when x is a positive number. When x is positive, you have a number divided by the absolute value of the number. In this case, when x is positive, the absolute value doesn't do anything, so it's just a number divided by itself, which is always 1. So there would be an open circle on this graph at 0, 1, because golf ball 0 can't go into the machine. It would cause division by 0. So we would have y equals 1. Consider now the second case, the case where x is a negative number. When x is negative, take -4 for example. You have -4 over the absolute value of -4. That quotient simplifies to -4/4, which is -1. And you'll quickly discover that whenever x is a negative number, this quotient simplifies to what? Well, you tell me. When I say go, I'd like you to say out loud and in unison what the value of this quotient is in the case that x is negative. Ready? Go. Yeah, you're absolutely right. It's -1. Do you have any questions on that? Yeah, go ahead. Go ahead. Speak up, please. Yeah. Right. Yeah, okay. That's a good question. The answer is no, you may not go to the bathroom unless it's an emergency. Further questions? Okay, sounds good. Let's go on to the next example then. I want to do another example from the book, just looking at page 166, problem 64. Okay. 166/64 is a piecewise function. The definition for this piecewise function is 2x plus 3. The rule for placing golf balls is 2x plus 3 in the event that x is less than -1. And the rule is 3 minus x in the event that x is greater than or equal to 1. I'm sorry, that's greater than or equal to -1. All right, so this is practice of what we did earlier in class. Go ahead and sketch the graph of this piecewise function. While you do that, I'm going to switch the music over to Fresh Air 5. The theme of Fresh Air 1 is spring. Fresh Air 2 is summer. 3 is fall, 4 is winter, I think. Fresh Air 5, they leave the Earth altogether, they just go to the moon. And the title of this song is Earthrise. It's an instrumental piece that gives you the feeling of what it would be to stand on the moon and watch the Earth rise, just like, you know, we watch the moon rise or the sun rise. It's Earthrise by Mannheim Steamroller from Fresh Air 5. Try to see if you can hear the part in the music. Can you pick out the part of the music that signifies the rising of the Earth? Listen carefully as you sketch the graph of this piecewise function. That was it. The Earth has risen. Very perceptive. Alrighty. I'm plugging in the boundary value. -2 plus 3 is 1. Open circle at -1, 1 with a slope of 2. Now I'm going to plug in this boundary value. Golf ball -1 actually goes to a height of 4. So, plug that in. Make this the blue leg. This ends up being the black leg. The blue leg of the graph. Has a closed circle at -1, 4. And, that's weird. When I wrote the point -1, 1, I only wrote one of its coordinates. Kind of unusual. But yeah, it's -1, 1 are the coordinates of this point. Which actually you can see from right here, so I'm just going to erase that because it's getting in the way of my blue point. My blue point has coordinates -1, 4. Now that the golf balls are being placed at an altitude of 3 minus x, the sequence of golf balls forms a line with slope -1. Down 1 over 1. Goes like this. I guess the intercept would be here at 3. So if you did this piecewise graph correctly, it has boundary points at an open end point at -1, 1, a closed end point at -1, 4. Already? And let's see if I want to do any more from the book here. Okay, yeah, this will be interesting. Number 19, I'd like to look at on a calculator. It's number 66. How would you do piecewise graphs on a calculator? So, we'll do it on both the 83 and the 89. When you do piecewise graphs on a calculator, it's a real feeling of freedom. Almost like the freedom that you feel when you're weightless in the atmosphere, returning from the moon to the earth. That's funny, that's the title of this song, is Return. This is the Return to the Earth music. Enjoy. All right, we're looking at problem 66.